Okay, so I'm Ben Taylor, Chief Data Officer, co-founder of Ziff.ai. I like to ski, so when I'm not doing nerdy things, I try to ski as much as I can. So real quick, my background. So I studied chemical engineering. I went and worked for Intel and Micron. So for any of the hardware people in the room, this fab here up in Lehigh, I think it's over a $6 billion investment. It's probably more than that now. When I first joined, I worked in a room that was called the $1 billion room. It was the photolithography room. So in one room, it was pretty small, smaller than the first floor of this building. They had $1 billion invested. And that money is going into photolithography tools. So for a single tool purchase, they'll spend $80 to $100 million. And one tool will have 8 or 9 robots. And they have a whole team of people staffed full-time just to do preventative maintenance and take them down. And if you don't know what photolithography is, the wafers, the semiconductor wafers go into this machine and it will print. There's a laser that shines a light, and then there's like a photochemical that will actually print the circuits onto the entire wafer. And so all of our iPhones, we have the 14 nanometer, Intel chips in memory. That's how they do that. And they're always coming up with ways to get it smaller and smaller, but we're kind of at the end. You physically can't make NAND flash smaller than 10 nanometers, and that's why everyone's switching right now to different technologies, because they can't make smaller circuits. So I did that for 5 years, and then I went and worked for a hedge fund. So the hedge fund, we built out $1 million GPU cluster. So we had 300 individual nodes. Each of them had 2 GPUs, and so we had people just building gaming boxes full time for like a month. And then I helped manage the grid. So we used Oracle SunGrid to manage our jobs, going out to this batch of computers.
Sorry, Commander.
Yeah.
How'd you go from chemical? Did you do chemical stuff at the?
So I skipped an important part. So luckily for me, I studied chemical engineering in Reno, and one of my professors was a big Linux nut, and he had Gen 2 Linux on his laptop. And so he's always telling everyone that we had to bail on Windows and switch to Linux. None of us really paid attention. We're like, yeah, we'll do that someday, probably not. And then the summer I graduated, I decided I was going to switch to Linux no matter what. And I think for all of us that have done that the first month, and this was a long time ago, feels like a long time ago now, so this is around 2007. So when I switched, there's a lot of things we take for granted, so like Flash not working, and I think a lot of that stuff is a little bit more seamless now than it used to be. But at least for a month and a half, I really hated my computer. And I think I may have even had the dual boot to get around it. But I had servers I was running at home. So I think that's where I fell in love with Linux, is you can run an FTP server and an SSH server and a web server. And you can do that stuff in Windows too, but it just seemed to make so much more sense in Linux. And then after committing to a summer, then I fell in love with everything you could do with Linux. I still consider myself, even though I've been using Linux full-time for a decade, I still consider myself a beginner, because there's so much more you can do. So the hedge fund, we built ridiculous amounts of hardware. The reason I joined the hedge fund is I had an interest in GPU computing, which is what this is. So everything we do, all of the computations take place on the GPU chip. They don't take place on the CPU. And at the hedge fund, we would spend an entire week porting CPU-based code to run on the GPU. So I was really proud of the fact that all of our code from beginning to end to results all took place on the GPU with no crosstalk back to the CPU, which was a real pain to do. And we hired these consultants from Chicago that came in. And for anyone who does software development, they'll appreciate this. These consultants, they would profile our code, because you have $1 million investment, and profiling your code is important because you need it to run faster and faster. You need to make sure you don't need a $2 million investment to run crappy code. So if you can make the code run faster, that's great. So we had these consultants come in, and the consultants would go through and profile our code and look at different things, these Pareto charts. And one of the elements there, so I was part of the quant team, they told the quants that we needed to transpose a matrix, which means turn it on its side, do the operation, then bring it back. So you're telling the developers to write 2 new operations to this already very expensive piece of code. And so all the developers are thinking, like, why would you do that? But these consultants actually knew the direction that the memory was striped on the chip, and sure enough, it was faster. So like things that developers would never think about. So that just kind of an interesting little tidbit.
So were you doing high frequency trading? Or?
No, it was all it's called sentiment-based trading, so it was trading on the news. We weren't actually generating the sentiment signals, so you can go write your own. I mean, and this is stuff that Dave and I we could do this if this is what we wanted to do. This isn't what we're doing, but you can go build a model to look at a news article. If you have some outcome associated with that article, like price action, you can build a model. So it'd be
an earnings report and
determine
whether that's
exactly
positive or negative. And
yeah.
Off of it.
So usually when people think of sentiment, they think of Twitter. Like, is this a sad tweet? Is this a happy tweet? But with stock, it's a different type of sentiment. It's more about price action. And then I went and joined. I actually went back to IM Flash for a year, but I wasn't necessarily happy with that change either. So I joined HiReview. So HiReview is a local company. They're backed by Sequoia. Most people have not heard of HiReview, but half of the Fortune 100 companies use us. So Goldman Sachs and IBM canceled all their on-campus recruiting because of HiReview. So I was their first data science hire, and I built out interview prediction. So the computer would actually look at your 20-minute video to go work for some company, go work for Google or someone else. Google, I don't think Google's a customer, but if you want to go work for Goldman Sachs, they'd look at your video, and the computer would predict how well you did based on everything you said, all your micro expressions, and your raw speech behavior, stuff that a human could see. But after working there for 4 years, humans are actually pretty bad at hiring. We bring a lot of biases to the table, racism, similarity bias, and we think we're really good at predicting who a top performer is, but most of us are keying on likability and things that aren't tied to long-term performance, because we just don't have the volume. Like personally, I've hired 4 or 5 people in my career, but I haven't actually, the computer can analyze 50,000 people, and it can actually follow them all the way to annual performance review.
I saw an article this month that was like the first startup to help people hire and remove all these biases, and it's like some startup at MIT, and I was like, I'm pretty sure Hire's been doing this for like 4 years.
Well, it's funny because we got attacked pretty bad on Twitter by some jerk from Purdue calling us out for transferring racism through our hiring practices. But this is something we've been thinking about for the last 3 years, and I actually got to speak in DC to the EEOC about racist AI this year. So you have the academics, and then you have people in industry that have more data than the academics could ever get their hands on. And he threw some publications at us, and it was like already way outdated from where we were. So so when it comes to racist AI, I think we have a pretty good, and actually AI, I'm a firm believer that artificial intelligence is the only way to remove racism completely, because everyone has it. So even, pick Mother Teresa or pick the perfect human in Utah Valley. If we could put 10,000 candidates through, we'd find some minority gender subgroup that it's just their upbringing. They're not trying to be malicious. So this year, love my job at HiReview, have a good data science team we built out, decided to quit my job with David Gonzalez, and we've burned the ships. We've been full-time. I've been full-time since February on this startup. And for anyone who's done their own startup, it's 100 times harder than you think it's going to be. And there's no such thing as holidays, and you work every day as much as you physically can. But it's also good, too, because you don't have red tape and stuff holding you back. I just threw this in here because it was on the meetup. So this was actually, so my wife really wanted me to quit the hedge fund because it was really stressful. And this was one of the compromises because I really enjoyed some of the parallel computing that we were doing on this 300 node cluster. And so I told my wife that, okay, if I quit, I'd really like some money to just go play around and build a little 10 node cluster in my house. And so this one, you can't see the final product, but what I actually did is these were the really thin Intel. So I wasn't doing this for high performance. I was doing this more for just like parallel troubleshooting, playing with some of these distributed file systems. But I actually I got an aluminum plate that would fit on all the heat sinks. And so this thing had no moving parts, and it was like less than a half inch off the wall. And I had a single heat sink for everything. So I was really excited about the idea of just like having some wall art or like some artistic copper, but you don't know that it's actually a huge heat sink using natural convection, hence the vertical placement on the wall to cool it. And I think this is where I kind of, with the hedge fund, I was already pretty sensitive to cloud, the benefits of going to the cloud. Because the hedge fund was an epic mistake to invest that much hardware rather than utilizing the cloud. So one of the reasons you want to use the cloud is you can pause your depreciation. So if Ziff, we've spent a lot of money. So this box was a $12,000 box, and we have another $20,000 box that I didn't bring. It's 140 pounds. We're putting it in a data center tomorrow. As soon as you make that purchase, your purchase depreciates immediately. It's like driving a car off the lot, except it's different than a car. Because these computer parts will literally go to zero. Like if you want to, I think you can go to U and you can buy like 1U web server Linux boxes for $60. But I think like the power bill's not even worth it. Like I don't even know why people get those, but this box here, even though right now it's pretty snazzy, it will go to zero. Where in the future I won't be able to even give this away, or I won't be able to justify the power to keep it going. And so the hedge fund, there was a lot of pressure there where the entire cluster had to be running extremely hot all the time, but humans can only keep hardware busy so often. We don't have enough ideas to keep the hardware completely utilized. Where on the cloud, at HireVue, you had the cloud account for the business, and then the data science team, we had our own cloud environment where we could spin up these huge studies and bring up ridiculous boxes and then tear it all down. So during that conversion to the cloud, I eventually pieced this all up and sold it and got rid of it because it just made so much more sense to play on the cloud. So this leads into this insatiable appetite for hardware. So something that's happening right now with people that play in artificial intelligence. So this is a plot that I made. Most people who deal with very basic AI, they're comfortable with this idea. So if you see some type of a scatter plot on your hardware or something, anyone can draw a line through it. You don't need to be a mathematician. You'll figure out that, well, this is the way it's going. This is a linear regression, or there's variations called logistic regressions for classification. This was really powerful. Even today, people still use this. But these models, you're dealing with a model that's kilobytes. Models have exploded very recently, like within the last 3 years, where now we have models that are a gig on disk. And we have models we deal with that are hundreds of millions of parameters and even billions. I know Google has some that are in the billions, where you've got, they've got 200 million images plus in some of their training sets where they're going through and training out billions and billions of parameters on these models. So to do that, you need really, really fast hardware. So this box that we built, it has 4 1080s, 36 teraflops. We built this a while ago, I can't remember. I think first of the year. It has 5 liquid-cooled radiators with aftermarket fans. So when I turn it on, it's funny because this may sound loud, but it doesn't sound loud to me and David anymore. Because the new computer that we have is insane. It's so loud, it's in my, so we've had it in my basement behind a closed door, like in the cellar, and when it's running hot, you can hear it on the 3rd floor of the home. So that's 2 stairs, 2 doors, doesn't matter how many doors you have, you're physically hearing it through the whole, so that's why it'll be good to be in a data center.
Your house this winter.
Yeah, it could, to your house. So it's, the data center set up there. We have to have it on yeah, it's going in the data center. It has to be on it's 3,000 watts, but I guess that's high enough. They prefer to have it on a 30 amp circuit. I'll get through this real quick. So this is an example of how AI is disrupting all of our lives right now. If you haven't been impacted, you or someone you know may be in the future. So the year 2012, humans were still better at reading a zip code off of a letter. But since 2012, the computer is better than you are at determining what that zip code is. So can you guys tell me what that zip code is? You've passed the post office interview. if you can answer this question, you'll make $10 an hour at the post office looking at zip codes. So this is humans wrote, these numbers are written by humans. Any guesses? How many people for A? How many people for B? For C? For D? Okay, the answer is C. So you're looking at this and you're saying that's not an 8, but a human wrote that 8. So the benefit that the computer has that we don't is the computer can analyze larger data sets, and the computer doesn't really have an emotional response. And humans are really, in the end, we end up kind of being limited to our digits. This is a bad example for that, but humans have decided that there are 46 microexpressions on the face, which is a really silly concept because a computer's not constrained by that. A computer can say there's 5,000 microexpressions. And then we're also seeing that with like speech. Humans made up elements of speech. So the algorithms that have taken speech to text, they use this idea of a phoneme, which is like a sound part. And so the smartest humans in the world decided over the last 2 decades that there are like 80 phonemes for English, or 60 to 80, where the computer doesn't use phonemes anymore. So it's like, so humans are so limited with our ability to, big 5 personality, why isn't there big 10,000? Well, that's because humans were limited. This is a comparison to show you why, and I apologize because I know this isn't where you guys are all focusing right now, but the takeaway from this is higher accuracy is good, so reaching 100 is actually impossible. Maybe it's, no, I take that back. So for this use case, we could reach 100% accuracy. So what the computer is tasked with is it has to look at these handwritten digits, and it has to be able to predict what the digit is. And there's different methods that have existed. So these methods that have existed, they've existed for 100 years. They're actually pretty good. So before we even had a computer, someone theoretically by hand could have figured out some model that would take an image, which you can squash and just make a long list of numbers, and it would predict with 92% accuracy if this is a 0 or 9. With deep learning, which is that's what we're focusing on with our startup, it's 99.7. And it's not, the takeaway from this is it's not, to go from here to here is much easier than to go from here to here, because you're dealing with diminishing returns. So it's kind of like a sports car. So if I give you $1 million to have your sports car go from 6 seconds to 4 seconds, that's a lot easier than having it go from 4 seconds to 2 seconds. And if I give you 10 million to have a gasoline car go from 2 seconds to 1 second, you may actually hit a wall where you just can't do it. You now need $1 billion to figure that problem out. So same thing with machine learning. That's why deep learning, some data scientists, that's what people in our space call ourselves, as data scientists. Some data scientists, they think of these different models as like tools in your tool shed, where deep learning is totally different. It's like you go to the future and you come back with a tool that you didn't have previously. The expectation now is superhuman across the board, so text, image, audio, speech. So we actually have reports now, we had reports last year, but we have reports now that Microsoft, they're seeing examples of superhuman speech. So when you think of speech recognition, you think of like Siri. Siri is not the gold standard. So the computer, there are some cases now where the computer is better at understanding what was said than you are. And that's wonderful. That means in a very short time span, everyone will have a personal assistant. So just like we have our phones in our pocket, at any moment in time, you could ask your personal assistant a question that's not kind of a pre-scripted question where Siri is really limited. And same with Amazon. You're very limited with the types of questions you can ask.
What is the gold standard?
So Microsoft and Baidu, and I throw Google in there too, but Baidu was the first one. So Baidu last year, they said that they were getting superhuman accuracy on Chinese, which is a 4% word error rate. And then Microsoft this year, they announced that they're also getting a superhuman error rate, 4% on English.
With Cortana?
I imagine this is like with their deep learning, like R&D arm. So it may not even be in their core offering. And then the other thing the computer is better than you are just image recognition. Not for all types, but if I had to challenge you with telling the difference between like a tiger shark and a great white and a Labrador and a baby, and like let's say I came up with 1,000 different categories, the computer would beat you at looking at an image and deciding. what is what. So this is kind of a joke, but it's maybe not a joke. So you have these big revolutions that happen in our society. You have industrial, computer, web. And with these revolutions comes a lot of money. So you have a lot of people make massive amounts of money, but you also have huge disruption, so unemployment. So you had people that were rioting, the textile and the buggy drivers were rioting. Then computer, you have people that are getting replaced. But with big data, automation, and AI, with this revolution that we're just kind of starting into, we're expecting the biggest exchange of money. So there's a quote right now about, I think, Mark Cuban saying we may have the world's first trillionaire. So we have billionaires from this social web revolution, but AI might bring in the world's first trillionaire. And then they're also expecting the highest amount of unemployment. So in the next 10 years, they're expecting 7% of people currently employed will be unemployed at the current task. It doesn't mean they won't be re-employed, but they won't do what they do today. So that includes 3 million truck drivers. Even HireVue, we're seeing this. So HireVue, with their AI offering, they're kind of spilling over into what's called the assessment space. So you have people that had a lot of job security because they were PhDs, industrial occupational psychologists, where they are experts when it comes to designing a personality assessment for you that can then be used in screening for a big company. And what we're seeing is the computer is getting much better validations. It's better at adverse impact, racist mitigation. So on all the metrics they care about, they're being beaten. So I like going to speak those conferences because it's kind of, I'm like the hornet in the room, and it's fun. It's fun going there to kind of deliver the news that you need to open a book and ramp up on tech, or you're going to get replaced. People that are chasing AI are doing pretty well. You look at the 5-year stock returns, especially Nvidia. So Nvidia, I think in the last year and a half, they've gone up 160%. So Nvidia has a monopoly when it comes to AI hardware providers. So anyone that's doing deep learning, so Google has a tensor processing unit, which I don't think is publicly available, but it's on their cloud. But then for people that are doing stuff in Amazon or on their own devices, they use Nvidia GPUs. So there are other GPU providers, and you can do the same AI that I'm going to show you here today with that, except the problem is you don't get the community support. So at the hedge fund, 5 or 6 years ago, we were making the decision, do we use CUDA? CUDA is Nvidia proprietary. You have to use Nvidia drivers or Nvidia cards, or do we use something called OpenCL? So OpenCL was the other graphics card's reaction to what Nvidia did. So Nvidia was the leader, and they reacted and said, uh-oh, we need to standardize on something to react to this. We don't use OpenCL because those libraries and that code base is so immature, and Nvidia is investing so much money into ensuring that they are the AI leader that the whole community has just abandoned OpenCL pretty much across the board. And then the huge breakthrough. So this year, Nvidia announced a massive breakthrough on one of their chips. So normally, with coming from semiconductor, if I announce an improvement on a chip, it might be a 50% improvement or 100% improvement. So Nvidia announced a 12x improvement. So they said our chip this year is 12 times faster than the chip last year. And it was funny because we were in San Jose at this, the day before the press release, we were there and we were talking to some of the people there, and someone came up and said, hey, tomorrow they're going to announce this 12x chip. We're like, oh, that sounds interesting. And then the next morning, the stock market opens up 20% before the announcement. And so it's just funny because it's like, well, I wonder how many other people put in their morning trades that morning. So insider trading does happen. Just we didn't do the insider trading, but so these are some of the examples that we do. So the whole point of our startup is we make it really easy for companies to use AI, so they don't have to hire an AI expert. So we have APIs, we have a platform, we have a product where people can take images, and as long as the images are organized, like in the case of chat books, these images are good, these images are bad, these images are printed, not printed, and the computer can learn just looking at these images. It's called supervised learning, where the computer is just physically looking at the images over and over again. So it might look at the same image 80 times, and that is enough for the computer to learn. And for this use case, it was pretty big scale. So the computer went through, I think in total, like over 20 million images. And for most people, that is a ridiculously large number of images. To most people that do training, so if you guys decide this weekend you're going to go kick the tires and start playing with this, the data sets you'll pull down to start with, they're 40,000, 60,000 images. So to kind of break above that million or 10 million class, you really need special hardware to do that. And when we first built this machine, we were really excited for about 2 to 3 weeks, until it kind of completely exceeded its capability. And I think that will be true for the rest of our startup's life. So Nvidia have a new computer because of that 12x improvement. That's a petaflop. It's just 40 teraflops short of a petaflop. And for people, these aren't terms that we throw around typically when we're talking about computers. So rough calculation, our new machine, that's 130 teraflops. The one I didn't bring because it's 140 pounds and it's pretty big liability. So that machine, for you to get the same throughput, you'd have to go into the Mac store and you'd have to buy 25,000 laptops to get the same throughput. But you wouldn't get the same throughput because then you'd be dealing with network, like overhead. You wouldn't be able to talk. Those computers couldn't talk to each other. So the other thing we can do is this is an example of disrupting society. How many people have had their home appraised? How many people were happy with their appraisal? No. Like, sometimes we get lucky. Sometimes it's like, yeah. So if I'm going to come do your appraisal, I'm not properly trained to do appraisals, but I'm going to tell you how I'd get pretty close. I'm going to come in, I'm going to find out how many beds you have, how many baths you have, when was your home built, what's the style of the home, how many square feet. With that information, I'm going to go back 5 months. I'll find homes that are similar in the area. I'll take an average, and that's your appraisal. And doing that is not a garbage appraisal. I'm going to get, so one of the metrics that we use to score things in this case would be, it's called an R value. So 1 would be probably impossible. So 1 is perfect, and a 0 is complete garbage. So using what I just described, I'm going to get a 0.6. So it's pretty good. Using deep learning, so we have an algorithm that can actually look at all of the images of your home. So if you have 60 images for your home, the computer will go and look at all of them, and it'll also read the entire unstructured text description. And so the computer will literally consider everything and make a decision. And so you're probably thinking, oh, this is really good. It'll see my hot tub and my kitchen, but it could also be really bad for you too. Because like, if you having a hot tub in your front yard is a bad thing, the computer will learn that, and it will penalize you for it. So it's kind of a beautiful thing, because it takes with all of these algorithms that we train, the human inspiration and creativity is kind of thrown out. Because the computer literally goes from data acquisition to target objective, where before there was a lot of creativity. So like all of us would be whiteboarding and coming up, and even at higher view. So a lot of the higher view product that is still in production, there are elements of it that were inspired by me or members of my team or our executives, where we'd come up with an idea and we'd go and program it. Where the replacement is no human creativity, because human creativity really just stifles the computer's ability to innovate on its own. And it really comes down to the scale. So humans can't explore, when you're dealing with hundreds of millions of parameters in the space, we can't even, our creativity is kind of a joke when it comes to what these programs can come up with. We also have a data set, very large data set, where we predict hours of labor on a car for damage. So the computer can just look at a bunch of images on your car, and it'll predict how many hours are needed to repair the car, and then also predict the parts, like what parts have to be replaced. And I don't want this to take too long. This is actually a presentation that's been given before at like AI conferences. One of the things that we're known for is our ability to kind of extract facial data. So we have a very large data set. I think we're close to exceeding 30 million images right now. And apparently that's impressive. Because we were talking to IBM in Denver, and the fact that we have over 10 million individuals and we have all of this metadata on them they don't have that data set for their facial recognition for their own internal training. So it's an interesting data set. So we take this data set, and once we build out this data set and kind of curate it, we can train. These are average faces. This is an example of racist AI. So last year there was a beauty contest, upload your face, and we'll predict how attractive you are. Someone used similar approaches, though not as sophisticated, and the computer ended up being racist. So the top 50 people that were selected, 49 of them were white. And it's okay to have differences, like majority race versus minority, but the differences have to be similar to the incoming pool, and 49 out of 50, that's racist. Like the media is not spinning it. That's they just really screwed up. And so that's actually why we acquired, so we have our own attractiveness data set because we wanted to prove that we could do it and not screw up as badly as they did. And it's interesting because the racism is actually present in the data and it's global. So it's not just in the US. So you go to a country like in Africa where everyone is black and there is a skin bias when it comes to attractiveness. But there's ways to fix that. So even if humans are bad, we can fix it. Gender differences. So women are graded more harshly than men when it comes to attractiveness. So this was actually a contact. I don't know if you guys saw this in the news, that AI was able to predict sexual orientation with 90% confidence given 5 images for white men. So some people are pretty upset by this. I think the initial reaction is this is really evil and this should not be done, but there are good things that can be done with this for protecting against discrimination and stuff. I don't know what else you would use it for, but okay. So I don't want to run out of time. What's a good stop time, or what? Because I also want to show a live demo on this.
Probably no later than 8:30.
Okay, I can wrap up quickly on this. So as you guys get to know me, I have pretty low expectations when it comes to what people can do, myself included. So there's lots of examples where humans, we just set the bar so low, it's not. Like in HR, people are, I used to go speak at HR conferences and people were always surprised that you can really take an interview and get all of this predictive power out of it. And for them, that was just science fiction, but my annoyance was, you guys, like the other HR people in the room, they set the bar so low. It's not that impressive to be beating humans when it comes to recruiting. There's other things that are much more, like video games. So the same algorithms we run on this, they can actually play video games. So have you guys seen the Doom examples? Who's played Doom? So Doom, pretty scary game back in the mid-80s. Was it 90s?
Yeah.
Okay.
Early 90s.
Yeah. So I play Doom, at night with headphones on, those monsters. Yeah. So the computer is better. It's better than any human in the world when it comes to playing Doom. And the fascinating thing about this is the computer. So to back up real quick. So let's say I have you sit down and you're playing a computer game, and I turn the computer to super hard, and it's beating you. It's shooting you in the head, and you can't win. We're actually not that impressed. We're not impressed by that. And the reason we should not be impressed is the computer's cheating. The computer knows full game state. The computer knows where you are, knows everything about the whole game. These algorithms are different. So the types of algorithms we can train on this box, the computer is given the same information that the human has. So the computer is just reacting to pixel data. So imagine that. So the computer just watching pixel data is better at you than playing Doom. And it's fascinating. So the way these machines learn is they start playing Doom, and initially they're really bad. So initially the computer will just like wander around and pick up a health box, and then it may shoot a monster, it may not. But after playing a million games, the computer, it starts getting rewarded for doing better and better. And so if you're curious, go home and Google Viz Doom, like Intel, and you can watch YouTube clips, and it's perfection. So when the computer is shooting the monster with the shotgun, there's some kickback. The moment the shotgun is ready to shoot again, it's dead centered on the next monster. And it's just like, humans can't play at that perfection. So I have a personal passion project to have these type of algorithms play Call of Duty on the Xbox. And it would have already been done by now, but I've been having issues with the Xbox drivers. So if there's anyone if that sounds really exciting, you want to help me get around the Xbox wireless drivers, which I've been playing with the Linux laptop, because all I need is video data and game controls. And that's all the computer's given. So the computer's given, here's the video data, here's the game controls, and the thing that's even more fascinating, the computer is not just reacting frame by frame, the computer is reacting to a temporal buffer. So the computer, just like you would, the computer is taking in the last 5 frames or the last 10 frames. So that is what is going into the computer, and at any moment it is predicting all possible game controls, including do nothing. Because do nothing is actually a very interesting decision, which we do often in a game. You're deciding to do nothing, and the computer will also decide to do nothing, or it will decide to shoot someone. And
so I recently saw a video where they had AI playing Dota 2.
Oh yeah.
Players.
So yeah.
And what was interesting on that one is the AI was coming up with strategies that players had never thought about. Like there was one instance where at the very beginning of a match, the AI would take its character and actually go down to like just under half health. And for a while they thought it was like, is this a bug in the AI?
Yeah.
I thought what it was doing was it would go to half health and then bait. And it would bait the other player and then just pop a whole bunch of skills right off the top and get the first kill.
Yeah.
And get that extra XP boost. And so players were very fascinated on how the AI is now giving them strategies that they can take in professional matches.
Yeah. And I think that's why with like so right now with our startup we have 160 terraflops, but we have plans to purchase the DGX1. So we'll just with our little Utah startup, we will have over a petaflop of computing by next summer. And with that type of power, when you're playing these games, like your ability to discover things that humans could play for 1,000 years and they'd never discover that behavior. And so that's why I'm so excited to watch Call of Duty, because when you watch Call of Duty, you'll actually understand how a computer sweeps a room. Because when humans play, they naturally figure out how to like clear a building. Like they don't, like you have little 7-year-old kids and they're clearing a building effectively without having like military training, and they're not being idiots about it. Like they're obviously beating the 40-year-old men that are playing them, like me. Like I just don't have the hand-eye coordination. But with the computer, you'll be able to see how a computer might sweep a building, and I don't know. Hopefully I don't seem too excited about that, but I am curious to find out how does a computer, because the obvious, so that game is actually more impressive than Call of Duty because the computer is incredibly good with short-term reward. So like first-person shooter, no contest. These types of fantasy games, or like, I don't know the details of this game, but the reason this game is a big deal is I imagine it's more complicated than short-term reward. The reward is not coming to me in the next 30 seconds. It's coming to me an hour later. That's much harder to figure out.
It's known as a really complicated game.
Oh yeah.
It takes people like a year to learn the basics of like the whole game.
Okay. Well, and even so the controls are not the complicated part. So if you had 1 million controls, that's not the hard part. The complication is the strategy.
It's all the combinations of all the choices.
Yeah, combination of
There's
choices.
only one character allowed per match, and each character has its own skill set, and that's where the complexity comes in.
Oh yeah. So I was going to show you an example of some computer bias. So this was HireView's first attempt at gender prediction, which is kind of embarrassing now, but at the time we felt pretty cool. So if you don't have image data that are assigned to some outcome, in this case we could cheat. So we could just say, well, we have first and last name, so people named Benjamin, they're probably men. People named Sally are probably women. You can get this from census data, and it's okay if you make mistakes. So you could have a lot of mistakes. We could probably have 10% error, which we didn't doing that approach. With this, you get a large data set. Once they're labeled, so the computer, you can get improvements if you have averaging, where you'll actually cancel out the averaging. It makes the things that matter about the image pop more. This is a bad example, but we've done this with like MRI data. So if I'm looking at an MRI scan and I demean it or subtract out the average brains, it's amazing what it does to the image. It just makes the image pop. Because there's elements of the brain that aren't lit up very well, but as soon as you demean it, the differences between my brain and your brain and someone else's brain become very, very apparent when you demean. So this is common. Who's the most masculine man? So we have a model, we can now answer this objectively. Any guesses? These are James Bond characters, if you don't get the reference. So
Correct, yeah.
anything under 50% is considered a woman. So the young Sean Connery, the computer thought he was a woman. And this is actually pointing out a flaw in the first pass. So this first pass algorithm, it assumed the face was symmetric. So it's actually only trained on half a face. And since his face happens to be the most slanted, that probably threw it off. One of the interesting things is it was able to generalize on aliens. Like obviously there's no aliens in the training set. These three men walk into a bar, one walks out alive. So Mr. Bean, the computer has 99% confidence that he's a man. So, and so the issue that this is pointing out is an issue with the training set. So this is an interview training set where there are men with long hair in the training set, but they don't have beautiful long hair coming down. Like if anything, they put it in like a ponytail. And then Chuck Norris, he obviously has machine guns, but he has this open shirt. Like he has a long neckline, which the computer is not familiar with. And so the fact that it's saying 4754, the computer is telling us that it's not going to decide. So it's admitting that, look, Chuck Norris has a beard and he has long hair, so I'm right in the middle. So the new gender classifier right now is really, really accurate. So it's actually superhuman accurate. It's got humans make mistakes. So when you say what your gender is on the form, out of 10,000 people, 8 will make a mistake. So the computer only makes 2 mistakes in 10,000, and that was 2 years ago, where now HireVue can no longer, they don't talk about errors in 10,000, it'd be errors in 100,000. This actually shows you what training looks like. So while the computer looks, this is training on gender. So one of these very large models with 70 to 100 million parameters, all it's doing is it's literally looking at images. So it takes a group of images, throws them on the GPU, calculates what the output is on that network, gets an error back, and it does it again and again and again and again. And in the process of doing that, it is learning and adjusting weights, and it gets to really high accuracy. So 99% accuracy is pretty easy if you have a good gender classifier. And there's no human expertise. There's no one deciding that men have thicker eyebrows or higher hairlines or beards. The computer decides everything, just given data to outcome.
Sincere question about transgenders. How does that fit in?
So with that example I gave, 8 make a mistake out of 10,000. So the 8 that we checked, from HireVue's perspective, they're protecting themselves from what the recruiter thinks. And so from the name, the sound, the video, from everything, the recruiter's deciding that this person is this gender. When it comes to transgender, you would want to get labels. So you'd actually want to get these people are this specific transgender. So for the homosexual example, or the gay example, that individual built a training set. So we actually have a sexual orientation training set that's being put together right now on a very large scale. So millions of people, we have sexual orientation, and we could. We also have, we're collecting smoking behavior and alcohol consumption. It's amazing what you can get from a face. I think this is the most important one to at least get out before we end. So the real mind blow for people that are kind of exposed to AI. So the whole time we've been talking about what I would call classification. The computer will decide that this image is a puppy and this image is a cat. This person is a man, this person is a woman. So this is what we call classification. So this would be like a discrete outcome. And so with these big complicated nets, you can actually have anything you want come out the bottom. So I can have male or female. For the exact same net, just changing what's coming out the bottom, and the way I reward it for learning, I can have one number coming out the bottom. I could have age. I could also have attractiveness, which would just be a continuous number. I can also combine them. I could have 3 things coming out of one net. I can have beauty, age, and gender, where one of the outputs is deciding male or female and the others are continuous. And this is the one that kind of shocks people. I can also have a whole image come out. So this is a deep net. So this is called colorization. So this black and white image is put into the top of a neural net, and a color image comes out the bottom. Does that seem like black magic or like? So this net can do colorization better than all of the colorization people on Reddit. So there's like a colorization thread on Reddit that this guy was trolling, where he's uploading like his AI outputs in record time with no expertise. And so these networks are really easy to train. All you have to do is get a large number of images that you care about, and you make sure the inputs are grayscale, and then the outputs are color, which is just red, green, blue matrices. And it will learn what has to be done to produce the color. The other one below that is it's doing image repair. So these nets can actually completely draw an image if it's damaged. So they can really do whatever you want. This is kind of a lame example, but if you wanted to have it like, if I wanted to have an image of me go in and like a Britney Spears song come out the bottom, I could do that if those were somehow connected. Like if the reward actually made sense, I could do that. That doesn't make any sense, so that the net's not going to learn anything. But if you come up with some crazy example, one I saw that was really fun was animation, where the computer was given an image and it would predict future animation. So it has an image of someone like at the train yard, and it animates them walking. Where, like the colorization is already impressive, but that is really impressive. So the computer is just learning from video, or people are just sending it chunks of video where they send it the first frame, and the computer has to predict the next 5 frames. So the computer is learning like temporal, like based on this person walking, I think they're going to do this or that. So you have total flexibility with what you want them to learn.
So in the example of an image repair, so using James Bond, Jason Bourne, any of those movies where they have a partial picture of somebody's face,
Oh yeah.
can they populate out the rest of that face?
Yeah, that's what this is attempting to do here. So they didn't do a very good job, but I have full confidence that given enough data and a big enough net, it'll beat anything a human could do.
How, and again, I love the spy movies, that's my thing, but how quickly can that actually be done?
100 milliseconds.
I mean, fast. I mean, so
Oh yeah.
So when they're showing it in the movies, they've got a picture that looks like his face, populated, rotate, yep, that's him, go.
Yeah, that'd be 100 milliseconds.
Yeah. Wow.
So.
Enhance.
Yeah. Well, so that used to bug me in the movies when they do like they have a really crappy image and they like do the hyper resolution on it. So the deep nets, they can do hyper resolution where they'll draw. So if I have like a 20 by 20 pixelated image of your face, it'll up that resolution. You're giving it a lot of flexibility. It's going to literally start drawing things, like it may draw wrinkles and things on your face that aren't actually there, but it's doing the drawings based on tens of millions of individuals, so much better than a human expert. But yeah. So we actually did train a beauty classifier, so you can see output on different celebrities. So it's scored from 0 to 10. Most people are 5s. There's nothing wrong with being a 5. 5's average. 5 is great. We noticed like if you're getting above a 7, you're probably a professional model, or you at least have like it's a serious photo shoot for men and women. So one of the other things so sometimes this powerful AI can do things that you don't want it to do because you didn't anticipate it. And this is also how computers will take over the world, is AI experts will design something and then they'll overlook some behavior and then the AI will do something. So can anyone guess? So we're showing the AI tens of millions of images from the internet and that are scored by people. Can anyone guess what the AI learned that maybe we didn't want it to learn? It's kind of a hard question, and it's kind of open-ended. So what we noticed is, so the AI, it learned, so we scored 1 million photos of celebrities, 13,000 unique celebrities. The number one most attractive celebrity to the AI was a lingerie model.
The most skin.
Yeah, so it learned beauty, but it learned a sexualization booster, and that's all come from human behavior. And the fun thing with that is we have a not safe for work model that's for a separate project, and so we can actually use that model to cancel out that effect. And this shows you where the computer has learned. So this shows you, we can actually look inside these models and see what the computer is paying attention to. So for men and women, this shows you where the computer is paying the most attention to make the decision. And keep in mind that the computer was never told where the human was in the picture. So no one even told the computer where the faces were. These are just candid shots. They can be anything, people standing up. So the computer locked onto the face, and these are the areas of the face that it decided to invest the most attention to. And you also have to keep in mind, it's not using just those points to make the final decision. It's using everything, but it's using more attention on bottom of the nose, ears, and eyes, and lips, which are common plastic surgery modification points that no human told the computer that these points are important. But so it's kind of fun visualization. We have like a country. So one of the fun things we can do with our data set is we can have the computer try to predict your country of origin. So it can just look at your face and try to predict out of 218 countries where it thinks you're from. And then the other thing you get with these is you can also look in and see what like the second, third, fourth, fifth guesses were. So if the computer says I'm from France, I can see, well, how close was it? So yeah, so we're actually pretty impressed with the results, but we're taking a second pass on this and it should be much, much better. So it's kind of fun, like you can get the genetic test or you can just have the computer give you like a full breakdown on where it thinks your country of origin might be. Any questions before we?
So how good is it at coming back to understanding what the computer's actually finding? So on the image, it's easy for us to say, oh, it was looking at the eyes, the beard, the ears, whatever, but an image is maybe a different set than other data, but is there a good way of understanding what the computer's really deciding on? Is it the beard or is it just
it's much more
their hairs?
It's much more complicated. So the way these physically work is you'll take the image of the person, and the way I imagine is you have like a stack of pancakes, or imagine like a marble machine where marbles can go all sorts of ways, but as soon as I bring it into the first layer, it's actually pretty understandable. We can still talk about what's going on. So the heat map that I'm showing you, I'm just showing you the top 50 layers averaged. As soon as we go deeper, we lose that understanding.
Okay.
So if we actually go to the end, you're just going to get a spot on your face and that spot is saying this or that. So there's no value from the bottom, from the aggregation on the bottom layer, there's no value. But at the top layers, you can kind of pull out pieces. If you actually want to get specific insight into an industry, what people will typically do, like for emotion, if I wanted it to, sometimes they'll train the net to also output something that's human understandable. So I'm not thinking of a good example right now. So like for emotion, so I'm going to have a net that's going to predict microexpression. But one of the things we want for microexpression is, are you happy? Are you sad? Are you confused? What gender are you? We just tell the computer to output all of those things. So the computer can output, because in the end, like from the machine learning perspective, really what we care about is our ability to predict on unknown data. And outside of HR, that really should be everything we care about. So when I see new data, how well can I predict it?
Right.
HR is different because you need to predict it, but you also have to prove you're not racist or sexist on new data. So when it comes to the understanding and the storytelling piece, sometimes that's like a conflict where people want the storytelling piece because they want to feel better about, it feels good to like have some intuitive understanding of, like seeing those facial heat maps, that feels good.
Right.
That, oh, it found the eyes and the nose and the mouth. That's interesting. But it's not, we're quickly going, I think so. People are doing work to kind of get to the storytelling piece, but the problem with the prediction power is that a lot of times that's where the money is. And
Right.
so the money's going to move it. Yeah.
So do those, you said like the facial one, you do the first 50 layers show the heat map and then
Yeah.
it goes further. If you stop it before it goes further, is it less accurate or more accurate?
It would be less accurate.
Less accurate.
Yeah.
So those lower layers do something.
The lower layers
to
are,
improve the accuracy,
well,
but
so one of the things we didn't talk about, these very complicated nets where it's literally 100 million parameters and that image is being mixed, and by the time it gets down to the bottom, it's a very complex set. what happens before you make the final decision is a lot of times there's what's called a fully connected layer. And so before I decide if this image is a cat or a dog, if I go one level up, it's just 1,000 floats. So that big complicated matrix system came down, was flattened, and then that went to 1,000 floats. That is actually interesting, because if I go one level up to that 1,000 floats, that fully connected layer, what that represents are these are the 1,000 most important feature building blocks that the computer discovered. So if I asked you to draw a picture of a human's face, but I said you could only come up with like 8 drawing actions, like very simple, like a curve or this, we would think really hard and come up with them. So that's literally what you're getting at the end. So that fully connected layer is really rich, and we use it for other things. We use it. You can use it for image search, deduplication. So we're working on a faces search product. So if you have petabytes of video, we see your face. Someone gives us a picture of your face. We can search petabytes of video very, very quickly, like less than 10 seconds, and return all of the video events with you in it. And to do that, we're relying on unstructured indexing using deep learning, where your face is represented as that. The computer actually just represents your face as the 1,000 floats. And that is really powerful because you can do difference. Like I could actually, if I took 1,000 floats of my face and your face and my cousin's face would actually have a smaller Euclidean distance to this. Like it's just incredible.
Yeah.
But it required a gigabyte model to give us this.
1,000 floats.
Yeah. So once you get that, it's really valuable. Okay. Any other questions? I think that we can wrap up for this presentation. Then I'd like to actually turn this on and show you guys what. Okay. Should I unplug this? Okay. So this, I think for anyone who's built custom Linux boxes, it can be love-hate sometimes. This was a lot more hate. So to help you appreciate the hate, like you get, I think when you're buying stuff like this, you get really excited. Well, actually David knows I get frustrated buying because I'm indecisive. I hate this. I hate making decisions. I'd rather just have a hardware expert say, you want to do this on your box, buy this, and don't disagree with me on price, just buy it. I'd rather have that, because this, you have to like look for compatibility, and does this work with this? So once you actually pull the trigger and order something, there's a level of excitement there that you're getting something really cool. But then when everything gets in the mail and it's all disassembled, it's kind of cool until you start putting it together, you plug it on, and you turn the power button on, and it's not turning on. And you don't know why, and you take all the RAM out, you blow on it like Nintendo, and you put it back, and then it works, and you have no idea. So this box, we had to replace the power supply. So we started with a 1,200 watt. We increased it to a 1,500 watt. We leveled up on the premium status. We also had to completely replace the motherboard because we were having stability issues where the box couldn't stay up for longer than 2 weeks, and it would just reboot, which you can't have it doing that, especially when you're using it as like a server. And I think this happened when we were in like California, and it was awful, where I'm like telling this less technical person, like a buddy of mine, like go in my basement and like play with this to get to work. So this is working really well now. This new motherboard's rock solid. Haven't had any issues, hasn't crashed once. I did do aftermarket fans on these liquid radiators. So each GPU has its own liquid radiator, and the CPUs have a dual liquid radiator which physically could not fit up here. It's got 128 gigs of RAM, which is kind of our bottom threshold, but everything is overclocked pretty much. So the RAM's all over 3,000 megahertz, and then the CPU is like over 3.5 or 3.6, and it just works. And I think the most impressive thing are GPU temperatures. They hardly ever go over 30 C, where HireView has a similar box, and theirs is always 80, like always, because it's air cooled. So see how quickly I can. So I think we're plugged in, and I apologize for not bringing the bigger one. I have a YouTube. I actually have a Facebook clip. Maybe I should show that quickly, but you can hear it when it's running. So, I don't know. Does this seem loud? I don't think it's loud anymore. Oh, maybe I can plug this in. So I default to Ubuntu for everything, just Ubuntu server. So I'm probably not nearly as advanced as some of you guys are with your Gen 2 builds or your CentOS. It's not saying anything. Let's see. So I also took off the GPU plates. I felt like they were kind of hindering the cooling. Let's see. Oh, did it see something? Okay. So we still have to use powerful CPUs because one of the things we do is when you're dealing with really large networks, you don't want to overfit it because when you have a billion parameters, I can do whatever. Like you could overfit these things. So one of the things that we do to prevent overfitting, it's called data augmentation. So every time the computer sends data to the GPU, it actually changes it just a little bit. So like an image of my face, it might rotate it, it might zoom, it might do like some shearing, it might add some noise to it. And so that's the whole job of the CPU. So when these are working, the CPU is completely slammed on doing as many threads as it can, sending data to these GPUs as fast as it can. And then the vanity metric that we use are images per second. So how many images per second can we push through 4 GPUs? So the Nvidia box, they have a benchmark of 13,000 images per second. That's their $170,000 dollar machine currently. I don't know what the specs are on the new one. So we can hit about 2,200 images per second. So if you think about that, that's 2,200 images that are going from SSD through the GPUs and getting an output. And we're pretty happy with that. How many people use Ubuntu? What are the other OSs that you guys use? Like Gentoo? Fedora? Okay. Anyone use CentOS? Okay. I've heard some people argue that CentOS has, like, the same machine running CentOS should get slightly higher benchmarks on. I saw someone had a post, some supercomputing post, and I'm sure you could argue that with Gentoo. If you know what you're doing, you just strip everything out. this thing takes forever to boot up. Have you guys built any gaming boxes like this or liquid cooled? You have? Have you guys done any like the hard liquid cooled with the hard piping? Okay. Yeah, this seemed a lot less stressful than that, where you kind of don't know what you're getting. Yeah. 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 So this Nvidia, so sometimes on boot the Nvidia driver craps out like permanently. You have to reinstall it. It's a quick install, but I think for this demo, it's not going to happen. So I think later tonight or tomorrow, I'll just post a screenshot, like a screen animation to the channel and the outcome. Yeah, NVIDIA drivers can be finicky if you guys have played with them. Have you guys installed any NVIDIA, like the CUDA drivers?
I did
Yeah.
CUDA drivers. It works so well on Linux. It was almost easier to just run it in Windows.
Yeah. Well, it's funny because we've complained to NVIDIA about how they manage those drivers, because it should just be pick your like yum install or like you apt-get install and then forget about it. But they actually they split their drivers where you have to download CUDA and they have to download this thing called CUDA DNN. And so we've complained to them about it, saying like, why do you make us do two things to get the driver set up? And they've said the reason they do that is because they're on two different release schedules internally. So it's easier, which is just like a terrible customer service excuse. Like, no one cares if you're on two release schedules. Like, what I care about is, did it take me an hour to get the GPU drivers working, or did it take me 30 seconds? Like, that's, I don't know. But yes, sorry the GPU drivers crapped out. I'll post something later. And then if you guys have any questions, feel free to come talk to me. Or if, yeah, you come take a look at this. Okay. Oh, and the other thing I didn't call out. So this is actually one of our customers. They actually have this supercomputing chip in a drone. So the drone that's flying around has the ability to recognize whatever you want it to recognize at 60 frames per second because of this chip. So the old chip was a terraflop. This is the TX2. I don't imagine it's probably 2 teraflops or something. Nvidia did a demo where they were able to run 4 deep nets on 2 4K streams at 30 frames per second. So this little chip that idles at like less than 2 watts and it maxes out 15 watts is able to analyze 2 4K streams, 4 deep nets. So 4 different models, which is amazing. And this is just the development board, so you don't bang your head against the wall. You can actually just like...
On the drone?
Yeah, so this is...
The drone itself is doing all the computing?
Yeah, it's all doing it live. So that's a big shortcut on the AI, because you don't have to have like Terminator-style robots running around. You can just have flying robots doing everything.
Swarming.
Yeah, swarming. Yeah, so for them we're doing some object recognition, but this is how we do the development. So this thing is about $500. You can get started if you want to actually do some... If you don't want to invest into the bigger GPUs, this is probably the cheapest way to get started with an all-inclusive AI. Yeah, this is the TX2. But this doesn't have that Volta technology, so I imagine next year's will be... That 12x improvement is something that only happens once, I think, because it was a mathematical breakthrough,
Yeah.
and it only affects the type of algorithms we use, and so they've actually had to differentiate. They don't call it teraflops, they call it D-flops, because the new teraflop only impacts deep learning because of this mathematical shortcut they found, where if you're doing like computational fluid dynamics, there's no benefit. But
It's like how some people use the AMD chips for cryptocurrency mining, but not NVIDIA chips.
Oh.
Because they're tweaked better for that or whatever.
oh yeah,
They have more
per.
So like Nvidia like optimizes their algorithms, AMD just throws more constraints at it, and that's why it kind of works better.
It's just brute force.
Oh yeah.
Currency mining.
Well, this Volta chip that Nvidia launched,
This was like 3 years ago, so
oh yeah.
I'm sure Nvidia.
Yeah, I don't think they're chasing the crypto market. Because I think the crypto, there's also custom chips now that exceed a GPU's capability. So if you're really serious about hashing, like if you actually have like a hashing farm, you're not, yeah, you're not running GPUs.
Yeah, it's dedicated hardware that's optimized for doing
Yeah.
hashing.
So the Volta chip was a $3 billion investment on Nvidia's part, but it'll pay off. So like it'll pay off with us. Like we'll be buying some Voltas this year. So, okay. Well, thanks guys. Don't want to take up too much of your time, and appreciate being able to show off some of this geek art. Okay.